Hi, I'm an old guy and I do maths. And today we're going to do a little bit more than the title suggests. We will fill in the gaps in a transition matrix, but we're also going to fill in the gaps in this network. However, we're going to use the transition matrix to do that. Now, a little bit of explanation. What does all of this mean? Well, what we have is we have three vertices on this network. And what the numbers tell us is the percentage of people or things or whatever that over a period of time, whatever that period of time is, whether it's a day, a week, a month, a term, whatever, move from one to the other or stay put. Now, I said percentage, but these things are actually expressed in decimals. So to turn this into a percentage, you multiply by 100, in which case you get 30%. Right, now, there's some information missing. That we're going to use the matrix to figure out because it's easier. The other thing is just an explanation. These are directional, so this edge here with an arrow on it means that whatever it is moves from here to here, and that's 20% of whatever it is. 30%, 0.3 remains here, 40%, 0.4 remains here, 10%, 0.1 remains here. 50% move from A to N. Again, we don't know what they are. It's not really our business at this point. Our business is to figure out what's going on in these blank areas here. And we're going to use a matrix to do that. Now I've set up the matrix, and the order I've chosen is just to start with A, go to M, go to N, A, M, N. So these are our starting points. These are our finishing points down here. Okay, so let's get started with the information that we have. So if we start with A, 40% or 0.4 of whatever it is remains in A. So in this position here, we put 0.4. I'm lazy about putting in the zeros. Now, the next thing I'm going to do is I'm going to move over to M. Before I do that, I should say that what this means is that this is A to A. It's what remains in A, this position here, from A to A. Now, I'm going to do M, and I'm going to do the same thing, from M to M, which puts M here, in this column and in this row. So that is 0.3. And then I'm going to go N to N, as in what stays put in N. And that is 0.1, and that goes in here. So, first golden rule of transition matrices, this diagonal, top left to bottom right, hosts the values that you see here. That tells you what remains at A, what remains at M, what remains at N. Now, what other information do we have? Well, we know that from M to A, 20% or 0.2 move. So M to A, that is 0.2. We don't, at this stage, know about A to M. So A to M down here, we don't know about that yet, but we'll get there. What other information do we have? Well, A to N, A to N, which is down here, so leaving A, going to N. Down here is 0.5, that one there. What have we got? What else have we got? N to M. N to M is 0.6. That's N to M there. Now, I'm just going to go through these and tick each one of them off. A to A, 0.4, done. A to N, 0.5, done. M to A, 0.2, done. M to M, 0.3, done. N to M, 0.6, done. N to N, 0.1, done. Okay, so what does that leave us? Well, it leaves us all this material in here, and we have 1, 2, 3 numbers missing. Now, this is where a matrix is really, really useful, because there are 2 rules when it comes to transition matrices, or 2 important ones. The first one is that these numbers in the diagonal, as I said, tell you who stays put, who stays in their position, or what stays in its position. But these columns must add to 1. So A to M, I'm going to fill this in red, is going to be 0.1, because 0.4, 0.1 and 0.5 add to 1. So A to M is 0.1. We can fill that in. 0.2 and 0.3 leaves us with 0.5. So M to N is 0.5. And our last one here is 0.4. 0.3. Can't do maths. Should not be in charge of anything. 0.3. 6 and 1 is 7, and 3 gives us 1.0. What is that? That is N to A, 0.3. Okay, so errors and omissions accepted. That is how we figure out what's gone missing from here, or what was never included. And that has completed our transition matrix. Now, what would normally happen is you would have another matrix, some sort of column matrix, single column, in this case, in all probability, yes, with the populations, the starting populations of A, M, and N, and they would get operated upon by this transition matrix, and those populations would change over time. But that's really the subject of another video. Now, I hope that you found this useful. If you did, please like and subscribe, and I will see you next time. Thanks very much for watching. Bye.